So next, let us look at another question. Now we are playing with definite integral with a boundary there. So we cannot use a simple use substitution, but let us use trigo substitution. So what is appropriate? Let's compare. This is a form of a square, the constant, a square minus x square. The first part, right? A square minus x square. So let's consider to use the variable as a sine theta. Okay, so a is 2, right? So we'll start with that. 2 sine theta. Okay, so there's a mark there for us to choose the correct trigo substitution. Right, and then we are supposed to replace everything in terms of the theta. At the same time, you should consider to change the boundary of the theta as well. Okay, for example, here if we are to change the boundary, we see that the sine, this is the boundary of a t. So if we are to get the theta is t on 2, meaning the theta is inverse sine of t on 2. So for the upper boundary, when the t is square root 2, so what is the theta? The theta is inverse sine of t square root 2 on 2. Okay, so square root 2 on 2 is actually 1 on square root 2. You have learned it in your math 1 and math 2 last time. The angle is 45-degree angle, or actually 45 is actually pi on 4, right? Well, let's recall back on the triangle. The triangle. Okay, square root 2 on 2, square root 2 on 2, square root 2 over 2 is actually 1 on square root 2. 1 square root 2. The angle there is 45-degree angle. That's the form. Okay, so sine 45 is 1 on square root 2. The angle there is 2. So that will be the upper boundary. As for the lower boundary, when t is 0, theta is inverse sine 0, which is obviously 0, right? So as we change the everything in terms of the theta, do consider to change the boundary as well. So now the boundary is 0 to pi on 4. As we are changing this thing as well, the 4 minus t is 2 sine theta square. We need the dt. How to get the dt? We need to differentiate, right? Okay, so dt d theta is derivative of the sine is cosine. So hence, as we substitute the dt is 2 cosine theta d theta. And then for this portion, you would like to simplify first by factoring. 1 minus, this is 2 square, which is 4. Okay, we take out the 4, we have sine square theta, like that. And there's a 2 there as well. Let's put the 2 in front. And here we have an identity. Okay, what identity? The Pythagorean identity. What was it? Okay, sine square theta plus cosine square theta equivalent to 1. So that is why, again, okay, you have to get handy with your formula list, the formula given to you. Okay, and this portion, square root of 4, we can split. So hence we get 2 times 2 is 4. Do consider to put your constant up front. So 1 minus sine square. 1 minus sine square is cosine square. Square root cosine square. And hence, as we simplify, cosine square root is cosine. Cosine times cosine, cosine square. And then we are left with this again. We have done this before, wasn't it? Okay, why don't I leave it to you, solve it, and then plug in the boundary as well. The boundary that we got just now is 0 to pi on 4. Alright, okay. Everyone, I'll give you around less than 5 minutes. Pause the video and try this question 3 before we compare to the answer. So let us compare. Okay, so from where we stopped just now, okay, I ask you to recall back page 238. I hope that you have done so. So up to now we have how many marks? Okay, let's see. We have changed everything in terms of the data. Okay, good. And we need to change the boundary as well, so that it's easy for us to read later on. Okay, M1. And then we are to get rid of the radical by changing this 1 minus sine square into cosine square. We are applying the Pythagorean identity M1. And then we are left with cosine power even number. Okay, so in order to read or to solve this integral of a cosine power even number, we need to use double angle formula. To simplify, as we simplify 4 and 2, we get 2. So we have 1 plus cosine 2 theta. Okay, until we get that. And then we can separate the integral. Okay, as for on how to solve this, we need to use a simple U substitution. Hence we are able to read in terms of the integral. Integrating cosine is sine. The 2 and 2, okay, cancel off. So that is the answer in terms of your theta. You need to replace back. Alright. And then for the definite integral that we have changed in terms of a theta, so plug in upper boundary minus the lower boundary. Okay, replace everything in terms of the theta in terms of pi on 4, and then replace the theta as 0. Here this is 0, so we get pi on 2. Here we have sine pi on 2, which is sine 90 is 1. So that will be our final answer. Make sure that you have all the work for you to deserve the full mark. Let us count how many marks do this question carry. So this question I give 9 marks, and see how much mark that you get. Okay, don't stop there. This is mathematics. Okay, the more that you do, inshallah, the more that you will understand. You just need to get familiar with the working. Alright, okay, that is for question number 3.